Hello and welcome back. You have multiple things to do in the exercises in the first week. First of all, you should form a group of 2 or 3 people. No groups of 4 are allowed. So if there are 4 people in a group, you need to split to 2 groups of 2 people. You need to decide on the topic. What is the trendy software engineering topic you want to work on? You can also form a group based on common interest. No group or no 2 groups should have the same topic. However, it is possible to have multiple overlapping topics, as shown in the slide. For example, group 1 could work on test automation, group 2 could work on Android test automation, groups 3, 4 and 5 in this example are working on different test automation tools, Selenium, JUnit and Appium, and group 6 is working on performance test automation. So this is an example showing how multiple overlapping topics covering the same area can be formed. But we can see that there are no 2 groups that have the same topic in these 6 groups. Additionally, you need to formulate and validate your search string. Remember that your search string really is your topic. You can use the web interfaces to test the results. However, later the data will be fetched through the web service interfaces that you need also to implement your searches into the scripts. Okay, so you start out by trying the results that different searches will produce. Let's assume that I'm interested in working on Selenium test automation tool and to perform trend analysis on the tweets, articles and Stack Overflow questions that deal with the Selenium tool. So I start by entering Selenium to Scopus and I perform the search. Now I need to check that the results are also valid. I can see the first result is about distribution and effects of natural selenium in soybean proteins and its proactive role in soybean bean clockine or something. Okay, so here I quickly realize that Selenium test automation tool gets mixed up with selenium, the substance that's in the food. So what I want to do is go back and make this search more refined. So I require that in addition to the word selenium, I also have the word software in my hits. Now I see again the top result. Now this looks much better. Automation software testing on web application. However, I can see that the second result is still not very good. Neither is the third result. So I still have to iterate to get the more refined result. Now to improve the search, there are multiple things I could try. For example, I can look at the result 2, biosynthesis, and figure that I don't want the word biosynthesis in my searches. So I grab this word, come here, copy it. Now I just go back. We add testing, and this is something software. And then I select and not, and now I put in here the biosynthesis. So that should get rid of the biosynthesis papers. And it does, but I still see that there is selenium papers that are not so relevant. So I can also try something else. And this is to focus on the subject area here on the right. So I can select only computer science, and maybe I'm also interested in engineering. And Right, and everything else I maybe want to exclude. And now I say limit. So I want to focus on this. It would also be possible to do exclude, which would be the inverse previous. Okay, now I look at the results. So I got 131 hits, automation software testing of web application, testing practices. Right, but there's still some problematic results. Local electron intrication, environmental assessment of vacuum, and so on. So at this point I might even realize that there are many bad results, and I only have 131 hits left, and even many of them are bad, so I might actually want to expand my search and to include names of other test automation tools, for example. And of course, you students would do the same thing, that is, iterate your searches on the topic of your interest, not only in Scopus, but also in Twitter, and also in Stack Overflow through the web interface. Okay, back to the slides. You understand that it's very important to validate the input data you get and try to get it as clean as possible. It might not always be very easy. You should also pay attention to the amount of results you get. I mean, suitable amount of results would be minimum 500 hits from each data source. The reason for this is that if we have less than 500 hits, then doing automated trend mining with natural language processing, as we are doing in the exercises, does not make so much sense. So this minimum of 500 hits from each data source is a success-seed minimum limit. You can go under it, but I mean, well, let's just say that if you have all the sources with very little hits, it will be reflected in your grading of this coursework. There really is no maximum number of hits. However, I estimated that the computing power needed for processing over 10,000 items might be a problem. The reason I say it might be a problem is that during last summer, I upgraded the course scripts to use a new implementation of LDA that promises to be 10 to 15 times faster. So it might be actually possible to use 20,000 items or even 30,000 items, but I'm not sure. Then you would need to get the scripts for the trend mining from GitHub, get data from all sources, Twitter, Stack Overflow, Scopus. In order to do that, you need API keys, at least for Scopus and Stack Overflow. And finally, you should execute scripts, get scopus.r, get twitter.r, and get Stack Overflow data.r. And finally, you store the data. Okay, so you go to the GitHub, m3s/trend mining, and you can find the scripts for this course. Also, if we need to make any updates, we will be serving them you through the GitHub. Here you can see brief description of the scripts, all the scripts that are available, and then there is a mini user guide. However, if you run into trouble, you should ask the assistant in the exercises for more details. And finally, there is some history and references on where these scripts have been used. So now we just clone everything to a local computer. So we take the address here and we copy. And now we we clone the repository to the local computer, hit clone, and now the address there. We get trend mining. Like that. Okay, so now we have the scripts from GitHub. The next step for you is to get data from all sources, but you need to start out by getting the API keys. I will not cover this in the lecture, so next I will demonstrate how to execute the get scopus.r. Excuse me, get scopus data.r.